Hi again, everybody. This is Joseph giving another tutorial, and this is about symbols of schematics, how to read schematics and understand schematics, because it's such a confusing topic. We have to go over it and try to fully understand it. Just like a road map tells you where to go with your car, it's the same idea with the schematic. You have symbols that designate what the components are and how they are interacted together. Now, always starting with basic electronics, there's always a source, a voltage source. It could be two batteries, such as in this case. You see the small line and the big line. Then you see a small line and a big line. That means there are two cells in this battery. So, even though it doesn't say how much the voltage is, the battery always contains a voltage, a force, they call them. A force in electronics could be designated or abbreviated as the letter E, or it could be abbreviated as the letter V, as in Vicky. So, we have a voltage source over here, which we need to send an electron flow, a current flow, to the component that we want to have the current flow and produce the work. That is designated or called the load. In this case, it is called a bulb. It could be in your house. You have a bulb or a light that you want to light from the AC source. That would be the load in this case. If you have a refrigerator, that would be the load. Now, as you see over here, again, we always have to have a potential of difference, a voltage source, a negative and a positive. So again, if these two, small one and big one is 1.5, and I have another small and big one, that's 1.5, they are in series. Therefore, they would add, giving us 3 volts as a power source. Again, it could be batteries, it could be an actual power supply. But this denotes it's DC. DC means it goes in one direction. The current flow is in one direction. AC would mean it would go in one direction. Change polarity, it means it will go back in the other direction. So right here we have a DC voltage source. Over here, we know we have to have a connection from one battery or source to another component. That's where these lines play a role. They tell us we have to make a connection from the negative of this voltage source, this battery, to this component, which is actually a meter that measures current. In this case, if you look at it, we want to measure how much current is flowing to the bulb to make the bulb light by a battery. Now, excuse me, as current flow, there's always two different opinions. Is it electron flow? Is it conventional flow? Is it going from minus to positive or positive to minus? In electron flow, the current flows from minus to positive. Conventional flow, it will go from positive to minus, such as in automotive. The idea, or the basic idea, is it doesn't really matter the direction as long as we have current flowing to the bulb to make it light. And therefore, in this case, we're going to go by minus to plus. Again, this tells us there is a connection with a wire from the negative over here to an ammeter, which is an instrument that measures current. Just like a gauge in your car measures a speedometer that I've done so many videos about, this measures current. We want to know how much current it takes to make this bulb glow. So we make a connection from the minus of the battery to the minus of this gauge, instrument measuring gauge called an ammeter. This gauge has also polarity, a minus and a positive. When it comes to polarity, minus of the battery has to be connected to minus of the ammeter. Again, if this would be positive over here, then this would have to be positive. They always have to match. Of course, if there's a minus, that means there's a plus. That means we make a connection now from the plus, the other side of this instrument called an ammeter, measuring the current, which is a red lead, to one side of the bulb. Doesn't matter what side of the bulb, because the bulb does not have polarity. A battery has polarity. This meter has polarity, but this bulb does not have polarity. So therefore, we could take the positive, which is the red lead, and make a connection from that to one side of the bulb. Illustrated here is a schematic component over here. Therefore, we can make a connection. We can make it with one wire, or we can make it 2 wires or 3 wires together connected. But really, the rule is try to use as less wiring as you can. So therefore, if I can make 1 wire from here to here, that's sufficient. I don't need too many wires to go from one point to another point. Again, now the other side of this bulb. Now remember, there's one side going to the meter. This schematic tells me the other side. As you can see, this is the other side coming out. Again, no polarity. The other side of this goes to the positive. And again, a connection is made from here to here. It could be, again, 1 wire. It could be 2 wires, 3 wires together with alligator clips. It does not matter. The current does not care how many wires you put together. But for basic electronics and for easier how to connect things, it's always easier, like I said, to put 1 wire if you can. The less wiring, the more easier it is. Again, and this is how you make a schematic, and this is how you connect the schematic. So therefore, as you see over here, current will flow from the minus plate of the battery or the power source through the wires to the minus, the black lead of this ammeter, to the positive side of the ammeter, coming out to one side of the bulb, make it glow, make it light. The other side, the current will flow back to the battery. As you notice, we need a complete path for current to flow. If for whatever reason, if this wire would be broken here, therefore current cannot flow through the whole circuit. You cannot say that the current will only flow to the bulb and stay there. No, current needs a whole path. Remember this, a complete path for it from the source, coming out of the source, coming back to the source, whether it be an automotive battery, whether it be a power source, whether it be AC. We need a complete path for current to flow. Therefore, if this was open over here, current cannot flow through the whole thing. If there was a open over here, a broken wire here, current cannot flow. If there would be no load here or it would be defective, there would be no current flowing. Every component has to be installed and everything has to be complete. Now, simple other one again. We just said we need a power source. 2 cells. A minus goes through the bulb. And to one side of the bulb. The other side of the bulb goes to, again, through a connection, through wires, through a same instrument measuring gauge called an ammeter. A represents an ammeter, measures amps or milliamps. How do we know that the minus goes to this side? Well, because the minus is here. Therefore, the polarity of this measuring gauge also has polarity. This has to match the battery source. So if there's a minus here, this has to be minus. The other side is a positive. The positive goes back to the positive. This is actually the same circuit as the other one. We're measuring how much current can flow through this bulb to make it light. I hope this was instrumental, informative. Please to subscribe to my channel of automotive electronic schematics by Joseph. As I said before, I need 1,000 subscribers. I would appreciate as many as I can, obviously, during the first year. I hope you can find some videos there for automotive that will really make you informative and helpful for you and thought-provoking. Thanks for watching. See you soon.